Hello everyone, I'm Tushar. I work as a partner engineer Android in Meta, and today we are going to be talking about user-initiated data transfer jobs. Before we get started, I want to mention a little bit about the work which we are doing in Meta in the partnerships. So I work in Android partnerships, and we are focusing on Android OS readiness program. This program, we every year try to target the newer SDK available as soon as possible for all the Meta family of apps. And in yesterday, in Ask Android as well, this was mentioned that how Meta targeted target SDK within 1 to 2 months of AOSP release, which was 4 times the velocity of what we previously used to do in 7 to 9 months because of the size of the Meta apps. Some of the other works which my team works on includes finding all the breaking changes which we have in Android, newer releases, and prioritizing them early. Part of it was also launched as a Ultra HDR features in Instagram. If you want to know more about how we are doing this in Meta, there is an Android developer article available with the title Embracing Android 14, Meta's Early Adoption, Empowered Enhanced UX. So feel free to go there, read about it, and let us know if you find it valuable. Moving on, today we are going to be talking about what were the previous Android foreground service changes last couple of years, what is user-initiated data transfer job, how we can write a UIDT job, what are the scenarios in which we can schedule a UIDT job, and how we can migrate our existing use cases to UIDT, and a little bit about the future prospects, what are coming up in future. Every year, Android brings newer changes to foreground services, and this has been going on for last couple of years. Just to recapture it, if you talk about in Android 12, we had that if your apps are targeting Android 12 and above, you can't start a foreground service from the background. So this is kind of a favorite topic for everyone, I remember. And then moving on, if you actually are targeting Android 12 and above and if you try to start a foreground service, it will result in a crash. So your app will crash. Next year, like moving on in Android 14, we got this new change that now you have to categorize each work which you are doing in Android foreground services with a specific type. And based on the use cases, you have to define it in the manifest, as well as you have to mention it in the Play Store with the specific use case what we are doing. Just to capture back, some of the types were camera, health, connected device, data sync, short service type. So basically, all your foreground service work needs to fit in somewhere in these types. And this was a big change which came in Android 14. I want to talk more about data sync, specifically to data sync foreground service type. Because this year in Android 15, we got to see that if you are declaring a data sync type, then your app will be allowed to run only 6 hours in background, subject to if you are bringing your app back, if your app resumes, then your limits will get reset. But in total, all of the foreground services in your app will be given a 6 hours of time period to run from the background. So consider a scenario like you schedule a work, your app goes to background, it takes more than 6 hours, it will lead to a timeout, and you will get a timeout callback, and it is forced that you have to stop your service. And moreover to that, if you want to know what is your stop reason, you can also get that. But the idea is that the restriction basically allows us that we will not be able to run any more than 6 hours. Now, this is the current state of foreground services year on year. And if we talk about there are more restrictions to come in future, I can say that because this year we saw that initially in the early developer previews, we got to know that data sync might get deprecated in Android 15. But later on, it was actually pulled back, and it is a high probability that we will see in future that data sync might actually get deprecated. Now, it actually brings the question, like, what are the data sync types where we can migrate our use cases alternatively? What are the alternate APIs available? One of the API is Work Manager API, but apart from that, a question comes to us like, what can be the alternate use cases where we can migrate? Now, in Android 14, we got to know a new API, user-initiated data transfer jobs. So UIDT jobs were actually based out of existing job scheduler APIs, and you can run them for longer duration data transfer that are initiated by the user. And if these are specific for the cases where we want to do any kind of data processing, maybe like scheduling, downloading a server from the remote, downloading a file from the remote server, or scheduling a backup job initiated by the user. But the caveat is that this needs to be based on the user action. User-initiated data transfer jobs are started by the user. These jobs require a persistent notification similar to what we had in the foreground services. And as soon as we have started the jobs, we will have to set notification to it. You can run several user-initiated jobs concurrently, which is a good thing. Like if you have multiple use cases, you can actually run them parallelly. UIDT jobs must be scheduled when the application is visible or in the allowed condition. So as mentioned, this allowed condition was something which I wanted to focus more. Like if your app is visible, that's a very clear use case where user can click on something and schedule a job. But what are the other alternative use cases where we should be able to run a UIDT job? So if your app can actually launch activities from background, it can also schedule a UIDT job from background. These involve certain specific scenarios where the system permits the apps to run that activity. It could be due to a click of a notification from the background, or if you have system alert window permission, or any specific other reasons due to which you can actually launch activities from background. If you want to read more about it, we have this detailed developer page where we can go and find out about this, but we will talk about it more in our talk as well. Moving on, how we can actually write a UIDT job. To write a UIDT job, we have to declare a job service in the manifest, and we have to mention the specific permissions which are associated with that job. Apart from this, whatever class we create, we will have to extend job service type for that specific class to make it a UIDT job. For UIDT, we have to actually add a uses permission in the manifest, which will tell the app that this is a user-initiated job, and it would be a mandatory permission add. Otherwise, your app can crash. To initiate a UIDT job, it is similar to how we do it in a job scheduler API. We create a job object. The only change which we have here is we have to set user-initiated true. So this specific flag tells the system that this job is actually running as a user-initiated job and would be separated out from the other jobs which we are running in the system. When the job is executed, onStartJob method would be called. In this callback, we have to first set the notification, and this needs to be done within like start of the job, because this is similar to the behavior which we see with the foreground services. So if we don't set a notification, it can lead to crashes and ANRs in your app. So this is similar to what we do there. Now, moving on, this notification will have to be updated as per the user. We need to show the user that we are doing some download work, and it needs to be persistently shown to the user. When the UIDT jobs are completed, we have to specifically called a job finished method. And this method will actually use parameters like true or false. So true means that this job has been failed and we might need to reschedule it. If we call it with false, it means that this job has finished the work and we have finished whatever work we have to do, and then it doesn't require a reschedule. This is actually a very important step while scheduling a UIDT job because this is a system API, and when we are, if we don't release the resources, this might result in your app actually running these jobs for a longer period of time, and which can lead to certain issues in your app where we are where we are using the battery more than what is required for the job. To run a UIDT job effectively, we have to define certain network constraints, job execution constraints, as well as the second point is the most important point, where we have to make sure that any work which we are doing in the on-start job has to be done in an asynchronous thread or in an asynchronous way using coroutines. The issue here is that if you try to do something in on-start job and we are doing it on the main thread, it can lead to an ANRs. To avoid running a job longer, we have to call the job finish method, whether it succeeds or fails. In UIDT, we have constraints defined which are similar what we have in Work Manager API. So we can declare the backup criteria, we can define our estimated network byte, or we can define which network you want to run a UIDT job, what is the network type. The last three use cases are very generic cases where we actually want to save. We want to do some types, like sometimes we have to schedule a work when your phone's battery is not low, when your phone is charging, or when we see that the storage is not low. So we can use these constraints and actually run UIDT jobs effectively. To test UIDT jobs, if we want to run it immediately, we can use the first command. This will tell the system that we want to idle schedule a job immediately, or we want to retry a stop job. Otherwise, if we want to simulate a system-forced behavior where your job is getting stopped, we can use the second command. Do we have backward compatibility for UIDT jobs? This is a very important question. Currently, the answer is no. Android actually allows UIDT jobs for Android 14 and above. So they are recommending us to gate whatever changes we have to do with the Android-specific checks for 14 and above. And for any kind of backward compatibility work, we have to use Work Manager's foreground service implementation as a fallback approach. So this is similar to what we currently might be doing. Only changes that there is currently no Jetpack library available, but in future we might see newer libraries based on this. What are some of the use cases where we can actually schedule a UIDT job from background? To talk about this, I want to go a little away from the topic and talk more about how actually Google improves consistency on background work. Recently, there was an article by Google where they mentioned that to strengthen Android platform, they are partnering with OEMs and they are trying to make the experience of scheduling the work and any kind of foreground work more consistent across the devices. And this is a very important step because it tells that any work which we are doing Android 14 and above, we can make sure that it would be consistent across all the devices. Now, how does Android make sure that the work is consistent across the OEMs? We have CTS tests. CTS tests or compatibility test suites are free, commercially grade available tests which are actually intended for the device developers to integrate in their workflow. And they can actually make sure that whatever changes they are doing to their devices are actually adhering to the Android guidelines. And it is a good way to make sure that your APIs are consistent. So this actually gave me some kind of an idea that, okay, if we can look out for some of the tests which are based on UIDT, it would be a good idea to understand the API better. So I found this class, user-initiated job test class, which actually defines the API behavior. I'm not expecting everyone to read through it, but I will quickly summarize some of the cases which I found through looking through the AOSP code. First one is you can run several UIDT jobs concurrently, which is already we have seen in the previous conversations. UIDT jobs cannot be scheduled from the background. This is also known. This one is the test which actually tells us that if your app has a notification and your app is in background, but user decides to click the notification, that gives us a small time frame where we can actually start activity from background. And in those scenarios, we can also run UIDT jobs. There is another test which tells us that UIDT jobs can be scheduled from the background, but they will not be running until and unless your app has been resumed. We cannot schedule a UIDT job from another job. This was one of the tests. Moving on, I found this test to be very interesting, where they have mentioned that if you have a foreground service which is actually started when your app was as the top app and visible to the user, then if that service is currently running, we can also schedule a UIDT job from that service. Alternatively, if you have started a foreground service from background, maybe for an alarm manager use case, or any specific other ways where we are starting the foreground service through system-defined services, then in those scenarios, we will not be able to schedule a UIDT job. I made a small diagram to understand it better. So if your app is in the top state, we can start a UIDT job. If a user clicks on a notification, then we have a small time frame where we can actually schedule the UIDT job. Otherwise, if your app is in background and we are still running a foreground service, and that foreground service was started when your app was in top state, then we can start a job. Otherwise, we can't. This captures the test completely. Now, there can be other scenarios where we actually can also schedule the UIDT jobs. For example, if your app has system alert windows, then it can also schedule a UIDT job from background. These behaviors are still in the process, and this is a new API, so I would recommend to keep looking in the documentation and AOSP code for more details, and also for any kind of a newer library available to make sure that we are following the Android guidelines. There are other background start exceptions which are available in the developer preview, so we can actually look into that before using UIDT jobs. Now the question arises, now we know how we can write a UIDT job, how we can schedule it, but why we should even consider migrating any of our use cases to UIDT. Android 9, actually, we had a new change which introduced app standby buckets. App standby buckets actually help the apps to prioritize the resources based on how frequently we are running the apps and on the usage patterns. Each app is placed into certain categories like active, working set, frequent, rare, restricted. So if your app is not used frequently, you might be put into a restricted bucket, and your app will actually be given a limited resource pool by the system. UIDT jobs are not affected by the app standby bucket. This is one of the important point which actually motivated me to look into more UIDT jobs. And basically what it tells is that even if your app is in certain specific buckets by the system, but then also you can actually schedule the work from using UIDT API. Having said that, the system can still stop the job if some of the other conditions can occur. For example, if developer-defined constraints are not met, if the system decides that the job cannot run for longer due to some system-defined constraints, if system has some other priority issues like health, or it finds some thermal state increase, or if your process is getting killed. So we need to take into account certain other factors where your app can actually kill the UIDT job. Apart from that, recently Google Map actually published an article about how they improved the overall map's reliability by 10% using UIDT jobs. What they did was they migrated their Google Maps offline download use case and compared it with Android 13, and they found that they saw a 10% improvement overall. We at Meta have seen similar results with UIDT jobs. The Android team's work actually found that if you are using foreground services or work manager for longer duration and user-initiated transfers, then those can be actually optimized using a UIDT API. Reduced memory usage and reduced notification clutter was one of the other factors they found when they were using the UIDT jobs. So apart from also increasing the reliability, they can lead to some of the performance improvements which were seen in the Google Maps application. So what use cases we can actually consider to migrate to UIDT? If your app needs to transfer some data to the remote server, or we have a large file download use case, or any kind of background prefetching work, then based on the user action, then we can consider UIDT jobs to implement that feature. Considering the restrictions which we are getting in foreground services, I would say like we have to start migrating our use cases to alternate APIs, including Work Manager, UIDT, and keep looking up for any kind of new APIs available in the future to make sure that whenever data sync type gets deprecated, we are in a good position, and our app's core use cases are not getting affected. What are some of the future prospects which we can look out for? Android team might bring more alternative APIs in future to help developers avoid background restrictions. We can expect these alternative APIs to be having embedded lifecycle awareness. So example is like if you are downloading a file and you have scheduled it, it needs to take care in the background. And even if your app is killed, it will make sure your download is complete. As mentioned before, Google is also working with other OEM partners to make sure that the consistency of the APIs are maintained. Thank you. This is all I had today. If there are any questions, we can also discuss.